Hi there, this is Leo, and today we're going to be talking about some group theory. In our first chapter, I want to define what groups are, and to do that we're going to talk about this new thing called a binary operator. All a binary operator is a fancy name for a function that takes in two variables. The variables can be as vague as you want. We could be talking about numbers, vectors, matrices, functions themselves. It doesn't really matter as long as you can form a set with these two things, as we typically attach it with a set and represent it with these two symbols here. You've seen it before as addition, subtraction, multiplication and division, and the greatest common divisor of two numbers also works. Now we get to the main topic of this entire series, which is a group. Simply, it's a set, and we attach a binary operator to the set, so we apply it to all the elements. And when we do this, it needs to obey four rules, or we call them axioms. We can represent a group as the symbol G, something called an identity E, and a binary operator, or just G the set. Now, the four rules are closure, which means we pick any two elements X and Y in G. X star Y, so applying the binary operation, gives us something back in G. Something called associativity means that if we have three elements X, Y, Z and G, if we apply X star Y star Z, putting brackets around the first two or last two makes no difference. The third operation is the identity we talked about earlier, E. Now, so there's a typo here because if we have X star E or E star X, they're the same thing. It should give us back X / E does nothing basically. And finally, the inverse rule means that for every element X in the group, there exists something called X inverse, which if we apply to X from either side, we get E, our identity. Our first kind of group we'll look at as an example is something called a number ring, which are the residues modulo 4, which is the set 0, 1, 2 and 3. We're going to do addition modulo 4, which hopefully you've done modular arithmetic before, and we look at the identity being 0. To check for closure, we pick any two elements from the group, let's call them X and Y. If we add them up, then the result, if we take it modulo 4, will also be in G, since they're all residues. Now, associativity we can just assume here, because it's a type of addition which is always associative. Now, as we said before, the identity is just 0, since adding it to any element doesn't change the element at all, which is the point of the identity element. We can check, since there's only 4 of them, each of their inverses. 0's inverse is 0, as always with the identity element. 1's inverse is 3, since 1 plus 3 is congruent to 0 modulo 4. 2 is self-inverse with itself. And 3's inverse is 1 because of symmetry. In fact, we didn't just have to pick 4, we could have picked any natural number n, and this still forms a group, Z/NZ. For our second example, I'm going to look at the rational numbers, usually denoted with a fancy Q, but here we add an X, and this is just the rational numbers Q, but we get rid of the element 0, and so basically it's all the rational numbers without 0. We do this because it's a group under multiplication, regular multiplication. And can you see why that would form a group? But here's it gets interesting, just the rational numbers themselves don't form a group. The reason for this being, of course, 0 is in the rational numbers and the identity is 1. So when we try and work out the inverse of 0, we get 1 divided by 0, which of course is not a rational number, it's not even a number at all. For our final example, we're going to look at the set 1, I, minus 1, minus I, where I is the square root of minus 1. This forms a group with complex multiplication over C, with an identity of 1. But what we should notice here is that it's got the same number of elements as with our modular arithmetic group, Z/4Z. This is going to be a really important concept later, as we discuss later themes in this course. And that's it for the introduction. I hope you do stay tuned for the upcoming videos, and I wish you all the best.